So in this video, we'll be going over L'Hopital's rule. So first question that comes to mind is, what is L'Hopital's rule and when do we use it? Now, when we have a limit, let's say x is approaching infinity, and we have some function f of x, and this, if we use direct substitution here and we are left over with, let's say, infinity, or we have 0 over 0, this is when we use L'Hopital's rule. So when you have either of these two conditions, infinity or over infinity, or 0 over 0, as these both are undefined, we need to use L'Hopital's rule, which states when we have, let's call this fx over gx, we need to derive the numerator and the denominator and then check for the limit again. So let's call this fx prime over g prime, and now we substitute the limits back in. X is approaching infinity or 0 or whatever, and then check for the answer again, or the limit again, and if it's still having infinity over infinity or 0 over 0, we keep deriving again and again and use L'Hopital rule. So now this will be very clear when we do some examples, and let's start with them now. And one last important thing is, when we have f over g here, we derive f prime separately and g prime separately. I mean to say, we derive numerator separately and the denominator separately. We do not use quotient rule or anything. So now we have an example here. Let me just cut this and let's write limit x is approaching 0, and we have sine x over x. Now if we use direct substitution over here, we will be getting sine 0 is 0, or let me write that down, sine 0 over 0, which is equal to 0 over 0. So we have one of the cases here, which is infinity over infinity or 0 over 0, so we have 0 over 0. This tells us that we can use L'Hopital rule here, as this is undefined. So let's go back to our limit, which is sine x over x. So now we derive sine x separately and we derive x over here separately. So this will be equal to, now the derivative of sine x is cosine x, and the derivative of x here is 1. Now we substitute the limits back. So when we substitute x is approaching 0, x is 0 basically, cosine 0 is 1, and 1 is a constant here, so we don't need to do anything. It will be 1 over 1, which is equal to 1. So it's pretty simple. We keep deriving until we get a definite or finite answer. Let's move on to the next question, where we have x is approaching infinity this time, and we have x over e to the power of x. Now again, if we do direct substitution, we will get infinity over e to the power of infinity, which is also infinity. So we'll get infinity over infinity, which we don't know what the answer is. Some people might say it's 1, but the thing you have to be very careful and think about is, which infinity is increasing at a faster rate here? Is it going to be just the letter x here, which is infinity, or is it going to be an exponential function? Since e to the power of infinity, as we know in our calculus, exponential functions increase at a very fast rate compared to a normal linear function, right? So just a thought there, just saying. So here we don't know which infinity is increasing at a faster rate. This could be, let's say the numerator is like 909, I don't know how many nines, trillion or whatever, but this is increasing at a faster rate than the numerator. So anyways, let's use our L'Hopital rule here. So derive the numerator and then derive the denominator. So the derivative of x here is 1, and the derivative of e to the power of x is simply e to the power of x. So it's important to know your normal derivatives of functions, logarithm functions, linear functions, and so on. So now let's substitute the limits again. So now we will get the numerator is a constant, which is 1, and again we have e to the power of x here. So it's going to be e to the power of infinity, and we know that 1 divided by infinity is 0, not 0 exactly, it's going to be very close to 0. Let's say 0 0.0, unlimited zeros, and then 1. So we can see or conclude that this is 0. So the answer here is 0, since it's going to be 1 over infinity, which is 0, because you are dividing a finite number by an infinite number here, and this infinite number is so big that you cannot think of, and as this is growing, this is gonna give you the answer of 0. It's gonna be so close to 0. Let's move on to our next question now. Or you know what, I'll leave this over here and I'll just scroll down. So we have limit x is approaching 1 this time, and we have ln x over x minus 1. So right away we can see that if we substitute directly x by 1, we'll get ln 1 over 1 minus 1. Ln 1 is 0, and 1 minus 1 is also 0. So we have one of the cases here. So let's erase that and now derive both the numerator and denominator. So the derivative of ln x here is going to be 1 over x. This is a rule. And x minus 1 is going to be 1, since we just need to find the derivative of x here, and derivative of x is 1 and negative 1 is going to be 0. Now let's simplify this. Let's bring x down here. So here we can take x down in the denominator. So it's going to be 1 over x, and now we can substitute x by 1 here, the limit, take the limit here, x is approaching 1 now, and test if this works or not, or do we need to again derive both the fractions. So here we get 1 over 1, which is 1 over 1, which is equal to 1, and 1 is the answer for this question. Now let's move on to more challenging questions. So it's going to be limit of x is approaching 0 here, and we have e to the power of x minus 1 minus x squared. Let's just now, it's going to be x over x squared. So now we right away try by substituting 0 here. So we will be left with e to the power of 0. Any number to the power of 0 is 1. So e to the power 0 minus 1 minus 1, or sorry, we are substituting x by 0 here. It's going to be minus 0, and then 0 to the power of 2 is also 0. So now e to the power of 0 is 1, so 1 minus 1, which is 0 over 0. So again, I'm mentioning this again. We can only use L'Hopital rule when we have 0 over 0 or 1 over 1. I mean, sorry, infinity over infinity. We cannot use the L'Hopital rule if we have 1 over 0. So keep that in mind always. Or if we don't have 0 over 0 and we have something like x multiplied by x, in the next example I'll be showing you guys, we need to somehow convert this into a fraction, and we'll learn how. So here we have 0 over 0, so we know that we need to use the rule here. So let's derive the numerator and then the denominator. The derivative of e to the power of x is simply e to the power of x minus 1 is going to be 0, minus x is going to be minus 1 over 2x. Now we try again by substituting 0 here. So when we substitute 0, e to the power of x is going to be e to the power of 0, which is equal to 1 minus 1 over 2 times 0 is 0. So again we have 0 over 0. So now what do we do now? We keep repeating the L'Hopital rule until we get a finite number. So again here we are going to derive the numerator and then the denominator. So we will get the derivative of e to the power of x here is simply e to the power of x minus 1 is going to be 0 since it's a constant over 2. since the derivative of 2x is 2. And now we again try for the limit. So if we substitute x here as 0, we will get e to the power 0 over 2, which is 1 over 2. And there we go, we got it, we got a number, an answer I mean to say. So half or 1 over 2 is the answer. Let's do another question. Limit x is approaching infinity, ln x over radical x. So right away we can try direct substitution. We are gonna get ln infinity over radical infinity is equal to ln infinity. So ln infinity is infinity over radical infinity is also infinity. So we are having infinity over infinity, so we can erase this and derive now. So ln in x, the derivative of ln x is 1 over x, as we mentioned before, and the derivative of radical x, I'm going to take it on the side. It's going to be, I'm going to bring radical as half power, and now let's derive this. So it's going to be half x negative half, and we can bring x down, so it's going to become half x radical, or we can say that this is half power. So we have 1 over 2x half. So now we can simplify this. We can bring the denominator down and we can bring this up, right? We just doing normal simplification here. So we are gonna get 2x half over x here. And here I can simplify this and get 2x negative half to the power of negative half. And now we can substitute infinity here, right? So we are gonna get 2, or let's bring x down. So let me write it like this first. Now let's substitute x as infinity. So it's gonna get 2 over infinity, which is equal to a number divided by infinity is 0. So the final answer for this question is 0. Now let's move on to a question where we don't have a fraction and we need to rewrite it or somehow make it a fraction. So we have limit x is approaching infinity, or sorry 0 plus x ln x. So the first thing that we notice is this is not in the form of a fraction, and if we substitute directly here, we are going to get 0 multiplied by ln of 0 plus, as we know, ln as it approaches 0, it is going to be negative. It's approaching negative infinity. So here what we have is 0 multiplied by negative infinity. And anyways, we don't need to substitute it first. We need to somehow convert this into a fraction. And what can we do here? Let me write the equation larger. To convert this into a fraction, what we can do here is a very simple step. This is x to the power of 1, and to bring it down, it is going to be x to the power of negative 1 over 1, which is the same thing as x to the power of 1, right, if we take this out. So what we have left here is ln x over x to the power of negative 1, and now we have a fraction, and now we can use the L'Hopital rule. Since if we, let me change this into 1 over x, it will be more simpler to understand. If we substitute directly now, 0 plus, it is going to be, this is the upper, ln x is going to be negative infinity. Since ln 0 is negative infinity, so 0 plus is also going to be negative infinity over 1 divided by 0 plus. So this basically is 1 divided by 0 0.0, endless zeros and then 1, and that is going to give you infinity. So here what we have simply is negative infinity divided by infinity, so we can use the L'Hopital rule. We proved that now. So let's derive the numerator and denominator here. So we have ln x, which is going to be equal to 1 over x over the derivative of x negative 1 to the power of negative 1 is going to be negative 1x negative 2. So this is going to be negative 1 over x squared. So here we can write it down, negative 1 over x squared. Now let's simplify. So let's bring this up, so this is gonna go up and this down, and we are gonna be left over with x squared over, this is gonna go down, oops, x, and there is a negative sign, so I'm gonna take it out. And now it's pretty simple, we are just doing normal division here, so x squared divided by x is x, and there is a negative sign, so all we're left with is negative x here. And now if we substitute the limit of 0 plus here, we will get x is 0, so the final answer would also be 0. Now let's just change the question by putting x is approaching infinity here. So then what do you think the answer is? It's going to be negative infinity, right? Let's move on to questions with E and Lin. So here in our next question we have Lin limit x is approaching infinity, and we have x to the power of 1 over x. So the first thing that we notice here that we cannot use L'Hopital rule since we don't have a fraction. So somehow we need to change this into a fraction so that we can apply the rule. So what is one way that we can do to bring the power down? It is going to be ln. So if we are taking ln of the right hand side, let's do y is equal to limit x is approaching infinity, x to the power of x, 1 over x. And if we take ln now, we are gonna take ln of the left hand side and the right hand side, since we cannot just enter a ln randomly. We need to remove it later onwards. We need something to neutralize this later. So I'll show you that how. It's going to be ln y is equal to limit x is approaching infinity ln x to the power of 1 over x. And now we can take the 1 over x down, since this is one of the properties. If you have a to the power of b, ln a to the power of b, a, b, so we can take b down as a coefficient of ln. So here we have the same thing. So here we can take, actually let me leave that down, it's going to be 1 over x multiplied by ln of x. And now we notice that we have a fraction, simply ln x over x, right? So here we can remove this and write ln x over x. Now we can derive the numerator and the denominator. Is going to get 1 over x, the derivative of ln x, and the derivative of x is just 1. We can take the x down, so it's going to become 1 over x. Now we can substitute x approaching infinity, so we are going to get 1 over infinity, which is equal to 0, right? Now the most important thing is that ln y is equal to 0, right? And we are solving for y here. Don't forget that we just added a ln here since to bring the power down. So we need to somehow remove this ln now since we are solving for y. The question is, you can think of this way: y is equal to limit x is approaching infinity, x to the power of 1 over x. Now how do we get rid of this ln? We need e, since e and ln cancel each other out. So here what I'm going to do is e to the power of ln y is equal to e to the power of 0. So e and ln cancels out. Now all that's left here is y is equal to e to the power of 0, which is equal to y is equal to 1, since anything to the power of 0 is 1. So the final answer here is y, or 1, is equal to 1. Let's move on to our last example. So it is going to be limit x is approaching 0, and we have 1 minus 3x to the power of 1 over x. So again, the first step is to somehow bring the power down and rewrite this into a fraction. And the way to do that is to take ln here. So I'm going to write y is equal to this question, ln y is equal to limit x is approaching 0, and we can take ln of 1 minus 3x to the power of 1 over x. We can take 1 over x down now, the property of ln. So we are going to be left with 1 over x multiplied by ln 1 minus 3x. Now we do have a fraction, so it's basically ln this question over x. So now we can use L'Hopital rule and derive ln. The derivative of ln is u prime over u. So here, what's the derivative of the brackets? It's going to be minus 3 over 1 minus 3x over x. The derivative of x is 1. And now just simply simplify this. So I'm going to take this down. It's going to become 1 minus 3x, and minus 3 is above. So now let's substitute x is 0. So we are going to get minus 3 over 1 minus 3 multiplied by 0, which is 0. And we get minus 3 over 1 is just minus 3. Now don't forget that ln y is equal to negative 3. So now we need to solve for y. So we need to again take e to the power ln y is equal to e to the power of negative 3. And we will get y is equal to e to the power of negative 3. We can type that on our calculator over here. And we will get the exact value as 0.04978 and so on. So as always, I do have a shortcut method for you guys for limits even. So let's go to this question. Okay, let's use this question. So we have here limit of 1 minus 3x brackets 1 over x, right? So what you need to do is we need to substitute a value for x. Let's try 0.0001 first, as it is very close, not very close. You can have like 100 zeros and then 1, but we are just trying to see the behavior of x here. So what we're going to do is we're going to substitute this in the equation 1 minus 3x to the power 1 over x and get the answer, and then increase the number of zeros and then see what happens. So here I got the answer of 0.04976. Now let's increase the number of zeros. Let's do 10 zeros maybe, or 9 zeros, and then see what answer we get. So I'm going to change here 1 2 1 2 3 4 5. Now I'm adding 10 zeros this time and see what answer that we get. 1 2 1 2 3 4 5. We got 0.04978, which is the exact thing that we got over here. Now you can also use this for infinities, by the way. So let's say we had this question, right? X over 1 over x. Now again, we will start by substituting x as 9999 and then increasing the number of nines and then seeing what happens to the answer. So here we have 999 to the power of 1 over 9999. We are getting 1.009. Sorry, there is another 0 over here. 92. Now increase the number of nines. So let's do 10 nines this time and see what answer we get. 2 7 8 9 10. We got 1 point, I don't know how many zeros this is, it's plenty, and then 2. So we know that our answer is correct. We are approaching 1. So let me do an example where we have infinity or negative infinity, so that I can show you guys. Yeah, let's take this example. I think the answer for this question was negative infinity. So here we have x is approaching infinity, x multiplied by ln x. So let's try. So try this question in the comment section and let me know the answer. And thanks for watching. If you have any questions, you can ask them in the comment section. I'll be more than happy to answer. And see you guys.